Welcome back, Science 7. Today we are going to go through Unit E, Planet Earth, Chapter 1.1, Lesson number 2. If I give you a little recalling, last time we had a little introductory class about something specific about Earth, and we learned that Earth is constantly in motion, constantly undergoing changes. Some of the changes are quite dramatic, like volcanic activity and earthquake. On the other hand, some of the changes are gradual, like how mountain ranges are forming. So today, we are going to elaborate from where we left off, which is why do scientists need model to study Earth in this case? And how do we know? So we are going to go through a little bit more detail in geography. Before we getting into, let's go to our homework check by going through science log activity number 3. So science log activity number 3 specifically was talking about why do you think geologists had to use indirect evidence to model Earth? And the question asking write at least 3 reasons. So one of the reasons, and again, just for the heads up, ladies and gentlemen, multiple answer can come out from this. But the very first reason is magma. When it comes to magma, we need to withstand high extreme amount of heat because magma is molten metals, if you can think of. It's not completely liquid. It's more about between liquid and solid situation. Number 2, we need to withstand enough of pressure, extreme pressure. And to be honest, ladies and gentlemen, the first two are one of the main reason, and those two cannot be separated. You guys, if you're into cooking, there's a cooking device called pressure cooker. If you increase the pressure, heat naturally increases too. So both of the components you need to think about. And when it comes to number 3, why do we have to use indirect evidence? It's because Earth has a lot of ages, and it's really huge. Earth's size, and if you put fourth reason, Earth's age. Some people may wonder why age plays a huge role. We need to actually know the Earth's age by studying the rock sample because Earth is about 2.2 billion years old. So the thing is, compared to the billion-year-old situation, how can we know how the Earth is formed and so on? We basically cannot. Human age, if we live long, maybe 100 years old, probably is one of the maximum, right? I know the technological development let us live longer, but like I said, we are not going to live like billion years. That's just impossible. So we are relying on indirect evidence in that case, like I mentioned, rock sample, sediments, layers. If you happen to go to Grand Canyon and at the same time Drumheller, those kind of area in Alberta, those are the ones that you can think of. So these are possible answers. When it comes to textbook question, I'm gonna go over in the next class because I gave you only half of it, and the other half you will go through that on next lesson. So just for the heads up. Let's go through some of the major structure of the Earth. The major layer of the first layer that we encounter is Earth crust. And at least when it comes to crust, we can observe it directly because that's where we're living on. Earth's most outer layer is the crust, ladies and gentlemen. So anything that you see ocean plate or mountain plate, we don't have much of a mountain other than the Rocky Mountain range, but you guys get the idea. Crust includes a lot of features. It includes mountains, valleys, plains, which is Alberta, hills, plateaus, oceans, and so on. If you think about the mountain area, this is how many mountain range that you see. The one thing that you know is what we have in North America, specifically US and Canada, Rocky Mountain. However, that's not the longest one. There's an Andes mountain range, which is what you see down there. We have Balkan mountain range, and so on. When it comes to mountain range, why do we have mountain range occur? We're going to talk about that way more detail, but if you consider in this way, things are getting a little easier. You don't have to draw this diagram. Imagine there's a plate and there's another plate. Obviously, where I draw my end down there is actually, so what I mean by that is this part and that part. Obviously, it's a hypothetical situation. It's not real, but in order to make you understand a little better, imagine there's a one plate over here. They're going on to west to right, west to east direction. On the other hand, there's another plate that go from east to west. You will have a collision site, and if there's a collision happen, like I said yesterday, some of the plate will go up, some of the plate will go down. That's how the mountain range is formed. You can look at valley situation too. Valley can be a little bit unique structure when it comes to Alberta, but if you think about any other places, I believe if you go to Montreal, Ontario, they have more valleys if I recall. Valleys are the ones that form between the ranges of mountains and hill. And as you can see, we have a water that goes through in the middle because of, yes, force of gravity, but those valley water will then connect it to the river, then connect it to the ocean specifically. We learn about this because one thing that you can put near there is, can you guys put this? Hydrological cycle. Fancy way of saying water cycle. So valley doesn't evaporate generally. Plains are something that you guys know. It's mostly known as a flat ground, very good condition for agriculture. Sorry, I got a typo over here. Agriculture. A lot of livestock industry, and that necessarily connected to why we have a lot of meat plant in our province, and at the same time we also have a lot of dairy products coming out. All those reasons, biotic factor. We have a lot of surface area, that means a lot of photosynthesis for the plant, and those are the ones that grazers eat, so that's how it goes. Hills, we say it time to time, if you happen to go to a south side of Alberta, not south border, so only some of them like Waterton, if you've been there, they have some structure like this. Hills are the one that is quite common in southern side of Alberta, and as you can see, and we learn about this a little bit too, we generally have a wind farm. You don't have to draw those three blades that go around. If you happen to go near Lethbridge area and so on, you will understand. Hills are the one, think about small mountains, not extreme as a mountain range, but it is repeating. Plateaus are the one that you probably seen it before in Badlands. I'm not talking about Las Vegas kind of thing, ladies and gentlemen, or gambling area. I'm talking about the scientific definition of Badlands. Those are the one that is exposed sedimentary layers. As you can see, we have a bunch of layers, and at the same time, those are the one where paleontologists go a lot, because most of the time it used to be either part of the ocean or it has a lot of fossils between those sediment layers and so on. You can visit probably in Alberta, Drumheller area has some. Ocean is something that is specific. We generally have multiple type of ocean. Probably some of you guys know Pacific Ocean. Some of you guys may know about Atlantic Ocean, Indian Ocean, those kind of thing. One thing that I really want to highlight, out of everything, I like to emphasize this picture the most, is because I want you to, I don't know whether you can highlight it on yours, you can put some kind of emphasis if you cannot highlight. There is a continental crust. Like the word says, continents are land. These areas are the ones that doesn't have water as a main body. So continents are generally heavy. But when it comes to other continents, I want you to understand that some crust are completely carrying waters only, or water is the main component. Water is a major volume. That's what I can think about. In this situation, as you can see, the ocean crust is going left to right. And when you think about continental crust, can you see that it's going right to left? So you can kind of see that connection on one on the left over here, one on the right over here. And because of that conflict, which is what you can see over this side, we sometimes have volcanic activity because of that impact. And sometimes if the impact is a lot, as you can see, we don't have a mountain range, but some rare cases we may have mountain ranges somewhere further down there. That is very common. And a lot of countries like Japan and Philippines, they are undergoing that volcanic activity, earthquake activity quite often. If it's America situation, Southern America, Chile relatively recently had a huge earthquake situation. So major layer, like I said, is the crust. Even though you may think, Mr. Kim, 10 kilometer and 90 kilometer thickness, that is a thick layer, you may think, but when it comes to earth level, this is actually thinnest layer, ladies and gentlemen. And humanity couldn't go further than that level unless you're in a magic school bus. There's an episode that class go way down the earth. But in any case, right now, we don't have enough technology to withstand the heat and pressure, but at the same time, we cannot even go to the bottom of the ocean. So we have a lot of indirect evidence. All of the biotic factors are found in here. And that part, ladies and gentlemen, I want you to put a little emphasis on the right side and then put your food web and food pyramid. Why is because if you think about food pyramid, this is a little recalling for you guys. We have a producer, so plants located at the bottom, but at the same time as you go over, we have a first primary consumer, which is herbivore, and after that we have a omnivores or carnivores on the very top. So as you may notice, we have quite a lot of interaction happen, and the most important reason is because of our bottom layer. We have to do photosynthesis. That's why in Earth crust we see a lot of living matters. On the crust we see a lot of minerals too. I want you to put one main reason. The reason that we have a lot of minerals is because we have rock. Generally bare rock is what we call. And like the water cycle, there is a rock cycle, which you will learn in future. So because that rock cycle happened near the surface of the earth, we have the most mineral. And some of the rock, they have all of those minerals like phosphorus and so on, copper, whatever, anything that you can think of, sodium. All of those are actually dissolved into river and ocean, which is one of the reasons why oceans are salty, seawater. And we have a lot of fossil fuels, oils, we are a petroleum province here, natural gases, and coals, ladies and gentlemen. Crust is very thin. Crust is very thin under the oceanic crust, ladies and gentlemen. And you can kind of see from this diagram the thickness is about one layer over here, but when it comes to continent, can you see that you need a lot of layers, like a cake in here? Crust is thick under the continental crust. So because of those two, like I mentioned, the density play a huge role. So when it comes to thickness, continental crust is more dense. The second layer that we're going to talk is mantle. Mantle is where you see magmas a lot. Molten metal and rock, ladies and gentlemen. It is a thickest layer. As you can see from this orange layer, that's mantle. It's 2,900 kilometers, what we assume it's about. So if you think about the Earth crust, which was about maximum 90 kilometers, imagine how much. This takes about 2/3 of Earth's total mass. When it comes to mantle, there is an upper part of the mantle and lower part. Upper part is relatively solid in here. The reason being is this area that is closer to the Earth crust, it's relatively cooler in this area. And it's going to get hotter when it comes to deep on the Earth. The solid upper layer part and the crust together form something I like to call lithosphere. So I like to say this is definitely solid when it comes to that. Solid and liquid, I like to put. These two layers, I want you to emphasize a lot together. What you see on the left has an ocean, so we call it oceanic crust. What's on the right? We call it lithosphere. Lower part of the mantle, like what you see on the diagram on the right side, it is composed of molten metals and rock. The temperature is extreme that metals choose to melt, rock choose to melt. This is one of the reasons why it's not entirely liquid. In order to make that, we have to have, please emphasize this, high temperature, high pressure. And these rock can flow very slowly because of one reason, very dense. When it comes to third layer, we call it core layer, but because it's located relatively outside, we call it outer core. These are the one where it's more close to the liquid. Because why? We are experiencing way more pressure, and because of that pressure, extreme pressure, you are experiencing extreme temperature. So those two are quite impossible to take apart. So very high temperature, very high pressure. The layer is about 2,200. You don't need to memorize the number. And when it comes to outer core, those are the one where molten rocks exist, and then they go back to the mantle, and then if there's any exchange happening in the earth crust, this is what happened. As you can see, as soon as magma flow through, can you see it's solidifying? So this is more liquid state, but at the bottom, see how fast it's turning from liquid to solid. So have that in your mind. Why do we have molten rocks only? Because the pressure is not great enough to make the molten rock into solid. Inner core, which what we think is actually not as a liquid. This is more of a solid. This is something that throws people out of the bus. So I'm going to elaborate a little bit in here. Imagine you have something. And imagine you personally have an unimaginable force. So you have a lot of grip. And if you try to squeeze things in, so imagine you're crumbling a paper so hard, then what's going to happen inside of your palm? Imagine you're squeezing those two using your both arms. Then you're going to have a very crumbled, solid paper on your hand. Imagine that logic, except the paper represents a bunch of rock and minerals and metals that is available on Earth. Inner core layer is known to be solid. It's the hottest area, but it remains as solid, and in order to understand it perfectly, you need to understand about nuclear physics, so I don't want to elaborate more. But in junior high science 7, I want you to know that this is where nuclear reaction is happening. And because of that, plus a lot of high pressure and temperature, we are having mostly a solid core. And most of the time you see iron actually. The weight of the outer layers press into inner. So imagine you have a pressure cooker number 1, pressure cooker number 2. So you have a solid, 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 extreme hard ball. And imagine the analogy as some of you guys who like movie like Hobbit or Lord of the Ring, imagine the blacksmith and solidified center as you can see in there. I know it's not the exact same thing, but that's a similar analogy. Inner core is mostly composed of iron and nickel. So that is my lesson for today. Your homework is doing science log activity to construct a table that summarizes each of them and unique property about that. Plus, fill some of the blank, what goes where. And like I said, the last 2 questions that I didn't assign last time, textbook page 556, number 1 and 4 are your to-do list also.